Here at the Eddy current unit, PhaseX 3D, doing a lab on non-conductive coating. And basically what we're doing here, we have a part. This is 7075 aluminum with paint on top of it. And essentially what we're doing here is trying to make, on our display, we want it to show different signals. We're gonna add these paper shims, you know, 1 stack and then 2 and then 3. Then we're gonna show different, we want our unit. So that's gonna be on the bare metal. Then we add more of those paper shims that we have over here. We want our unit to slowly reading closer and closer to the baseline there when we add more shim. And so we're gonna show you how we do that here. So display some of my signals, my settings here. Right, gain 31.5, 24.9, 270 phase, 300 kilohertz. This is the important stuff. All right, so now I'll show how we're looking on the screen here. So this is where the display is on the bare metal. It should be pretty close to bottoming out on our screen here. Look at that, that's about right on the money. So that's our bare metal on our reference standard. It's 7075 T6 aluminum, and we want to check to see if it's similar to our material. So there we are, there's the material, and then that's our reference. The long one's our reference bare metal, and the smaller one is our same chemistry metal, but it has paint on it. And so what we're gonna do is we're gonna stack our paper on our reference here to the right. And when we do that, we should gradually see this bare metal signal get closer to where it is on our part here. So with that being said, we can measure how thick our paper is, and we can get a good size and see how thick this coating is, which is the purpose of this lab, to see how thick this coating is underneath. It's pretty cool. Can't do it with a ruler, because you don't know how thick it is. So we're gonna unfreeze our screen here. We're just gonna show it again. I believe we're annulled in air. So again, this is our bare metal, and this is one sheet of paper. Wait for that. Yeah, that's one sheet of paper there. Oops, sorry, let's lift off. One sheet of paper there, so that's looking good. So that's one sheet paper here on the screen that's frozen. Now I'm gonna let it disappear. I'm gonna put my probe on the part. So that's gone, kind of keep a visual where that's at. So that's where we are, freeze. Now we're gonna go see where we're at on one sheet. Okay. So with this information, I know that right now, my sheet is pretty close to how thick this coating is. But we can narrow that down to be more precise so we can see. So we know one sheet's pretty close. One sheet's pretty close to our reference. And let's see how we are with two sheets. That disappeared. Okay, so that's two sheets. And so we could say it's definitely, our thickness is definitely less than two sheets. Then we'll do one sheet, much closer to, we measured our papers about 4 thousandths. So we could say our coating is a little bit less than 4 thousandths, right? And that's our bare metal, 1 thou. Once it goes, that was my part. It's pretty close. So we have a good indication that that's how thick our coating is. And of course, here's my lab sheet. If you keep adding more and more paper, my signal will get pretty close to that. I'll just put a stack of 3, 4, 5. Let's get these so we can do it proper. So there's that. So I'm unfreeze my screen. And this 5 is gonna be pretty close to where my spot is. So that's our bare metal. I want to dissipate. And there we are with 5 sheets. And this is our part, and you can tell, obviously, so 5 sheets would be about 20 thousandths, and we can say that is much thicker than our paint is on here. That's it for this lab.